Hello everyone, a very warm welcome to all of you. So most of you were requesting me to help you understand the concepts of anthropology and especially physical anthropology. So here it is. Today we will be starting with one of the simplest units of physical part of anthropology, and that is unit 9.4, that is chromosomes and chromosomal aberrations, right? This is a very simple topic, but only if you understand the basics. You do not have to ratify anything, provided you understand first the concept of chromosomes. What do we mean by chromosomes? Only when you understand this, only when you understand their structure, you will understand the errors in it. Because see, aberrations means errors. As you can see from the spelling here, ERR, that means errors. So errors in chromosome will be very easy to understand if you understand what exactly is chromosome. These are the topics that are there in the syllabus. So A, B and C, these three topics will be very easy to understand if you understand what is chromosome. So in this lecture today, I will be helping you understand the basic concept of chromosome. In other words, we will be laying the foundation of this unit today so that it's easy for you to learn them. And you do not have to even memorize them hard. It will be coming automatically, right? So these are the previous year questions that have been asked from this unit, and from this you can understand that this is a very important topic and a very simple one. So without wasting any time, let's begin. And yes, please like the videos if you genuinely like them, share them with your friends and subscribe the channel. Thank you. So let's start with chromosome. What do we mean by chromosome? As you must have heard that chromosome is our genetic material, but you must have also heard that DNA is our genetic material. So how is it happening? Let's see. Suppose let's start with DNA. This is DNA. We can go a bit slow, but I'll make sure that you understand every part of it. This is DNA, right? And this DNA is joined by weak covalent bonds or weak hydrogen bonds. That means these two strands, they make up of one DNA. They make up one DNA. One DNA is made up of two strands. You can see two threads over here, right? You can see two threads, one and two. So this DNA is made up of two strands. One DNA is equal to two strands. Unlike RNA, because RNA is made up of one strand, but DNA, it is made up of two strands. So you can see over here, there are two strands, one and two. And these two strands are joined by hydrogen bonds, weak hydrogen bonds. So this is one DNA. I hope this much is clear. Then what happens? This DNA, as I am drawing it again, this DNA is our genetic material. This DNA, now this is like a long thread. Suppose you fly a kite. So the thread with which you fly your kite is very long. So what you do, you roll it on charkha so that it is easy to handle the thread. Similarly, this DNA gets condensed to form chromatin, right? This DNA gets condensed to form chromatin. Please mark my words. Here it is N, chromatin, right? And this is condensed DNA. This chromatin is nothing but condensed DNA, right? Now, this chromatin further gets condensed to form chromatid, right? And this is called as chromatid, T-I-D. Here it is D and here it is N. This is the most compressed form, most condensed form of DNA. So DNA is also our genetic material and chromatid is being formed from DNA, so it is also our genetic material, right till here? Now, this DNA gets replicated. Replication of this DNA takes place. So on being replicated, there is another DNA. That means because this DNA has got replicated, so this is another DNA. Again, this is joined by weak hydrogen bonds. This DNA further gets condensed to form chromatin, and again this chromatin will get condensed to form another chromatid, right? And as you can see, this is chromosome. So how easy it is. DNA is also our genetic material, chromosome is also our genetic material, because chromosome is nothing but the condensed form of DNA. So one DNA gets replicated to form another DNA, one chromatid gets replicated to form another chromatid. So simply I can draw like this. This is one chromatid, this gets replicated, this gets replicated, and one chromatid, and this gets replicated to form another chromatid, and this is known as chromosome. The point where they are joined together is known as centromere. Centromere, or we can also say primary constriction, right? Centromere or primary constriction. I hope this much is clear to you. One DNA made up of two strands, DNA gets condensed to form chromatin, chromatin gets condensed to form chromatid. On replication, one chromatid or one DNA gets replicated to form another DNA or another chromatid. So one chromatid itself is here, it gets replicated to form another chromatid and they join together at the point of centromere, and hence this is known as chromosome. And these two therefore are known as sister chromatids because one chromatid replicates to form another chromatid. So these two chromatids of one chromosome is known as sister chromatids. Clear till here? Now, let's come to the human body. In human body, if you must have heard, there are 23 pairs of chromosomes. In other words, we can say 46 chromosomes, right? 23 pairs means 46 chromosomes. So if I draw them in pair, suppose I draw them here in pair 1, this is one pair, then this is second pair, and so on and so forth. We have 22nd pair and we have 23rd pair, right? So these are 23 pairs of chromosomes. Why they occur in pairs? Because one set of chromosomes, these are two chromosomes, one set of chromosome comes from mother and this complete another set of chromosome comes from father. One set from mother, one set from father, so they occur in pairs, right? Now, chromosome, this is first pair as I told you, and this is 23rd pair, this is 22nd pair. So, chromosome pair number 1 to chromosome number pair number 2. From chromosome 1 to 22, they are known as autosomes, right? Autosomes. And 23rd pair, that means this pair is known as allosome or sex chromosome, right? Sorry, from pair number 1 to pair number 22 are known as autosomes, and the third pair, sorry, the last pair, the 23rd pair is known as allosome or sex chromosomes. Now if you pay attention over here, it is easy to understand if we talk about autosomal aberrations. As you can see this topic in your syllabus 9.4, autosomal aberrations, that means they are talking about errors in autosomes, and autosomes are from pair number 1 to pair number 22. That means they are talking about errors in pair number 1 to pair number 22. So if they talk about 23rd chromosome, that means it is not an autosomal aberration, but it is a sex chromosomal aberration. So in sex chromosomal aberrations, we will be limiting ourselves to only this chromosome, this pair, 23rd pair of chromosome. Whether it's X or Y, that we'll talk about in next 2 minutes. But autosomal aberrations means from 1 to 22. For example, if there is an error in chromosome number 13, suppose we have this pair chromosome number 13, 13th pair, if there is an error over here, suppose from rather than two pairs, rather than two chromosomes in one pair, if we have three chromosomes, then it is known as Patau syndrome. Right, I will be dealing with all this monosomy, trisomy, everything in our next lecture. But today I am telling you how autosomal aberrations and how sex chromosomal aberrations are differentiated. If we have error in chromosome number 18, so it is known as Edwards syndrome. If we have error in chromosome number 21, it is known as Down's syndrome. So they are named after the scientists that discovered them, Patau, Edward and Down. So 13, 18 and 21. So you can remember them as PED. राइट पीईडी पेन की जगह पीईडी कर दो तो पटाओ एडवर्ड डाउन 13 18 and 21 right these are autosomal aberrations. Now coming to sex chromosomal aberrations. In sex chromosomes there are two types of sexes, or we can say two types of genders, female and male. In female both the chromosomes are X and X. We have a pair of chromosomes, so both the chromosomes are X and X in females, whereas in males we have one X chromosome and other Y chromosome. Now why we do not have YY? Why do we have X and Y? Because X is very important for the essential survival of the person, because X chromosome not only controls the female reproductive characteristics, we have in females both X chromosomes, So X chromosome controls female reproductive characteristics, plus it also controls very important functions like brain development, color vision, blood clotting. Blood clotting is a very important function, because if your blood will not clot, you will die. The person will not be able to survive, right? So if this male does not have this X chromosome, his blood will not clot and hence he will die. He will not be able to survive, because in case he get hurt, his body, his wound will not recover and hence he will die out of blood loss. So that's why this X chromosome is very important, and hence it is present in both females as well as in males. Now, what about this Y chromosome? This Y chromosome controls only and only male reproductive characteristics, male reproductive functions. Since X is controlling more number of functions, female reproductive functions plus brain development, color vision, etc. So that's why, since it is controlling more functions, it is bigger in size in comparison to Y chromosome. X chromosome is bigger in size, larger in size in comparison to Y chromosome. So, moving to the next story, as again I'll draw this. I told you there are 23 pairs of chromosomes, 1, 2, and so on. 22nd pair. Then we have 23rd pair. If it is XY, X is larger, Y is smaller, right? Now, autosomes and allosomes is clear to you. 1 to 22 autosomes and 23rd pair is allosomes. Coming to the next term, that is homologous chromosomes, heterologous chromosomes and non-homologous chromosomes. If both the chromosomes are from single pair, suppose this is pair number 1 and we are taking or we are talking about these two chromosomes. These two chromosomes are chromosomes from one single pair, so they will be known as homologous chromosomes. Homologous chromosomes, because both the chromosomes are from one pair, pair number 1. But if we talk about this chromosome and this chromosome, so they are not from one pair. One chromosome is from first pair, the other chromosome is from second pair. That's why they are known as non-homologous chromosomes. Non-homologous chromosomes, because these two chromosomes are from different pairs, right? Now, coming to the last pair, 23rd pair, if they are X and X, so both the chromosomes are from one pair, that means they are homologous chromosomes, because they are also same, X and X. But if we have X and Y, that means they are heterologous chromosomes. Now you will be thinking, why not homologous? They are chromosomes from one pair. See, if we talk about 23rd pair, if this is X and this is Y, though they are chromosomes of single pair, that is 23rd pair, but we will not say homologous, we will say heterologous. To differentiate between X chromosome and Y chromosome, to differentiate that they have chromosomes from different types of chromosomes, right? So it is known as heterologous pair of chromosomes. That means in females, if you take care, please focus on this point. In females, all the 23 pairs are homologous pairs of chromosomes. Matlab maximum there can be 23 pairs of homologous chromosomes, because the last pair, 23rd pair, is also X and X. That means homologous. Whereas in males, we have 22 pairs of homologous chromosomes from pair number 1 to 22, plus the 23rd pair is X and Y. To differentiate from other pairs of chromosomes, we term it as heterologous chromosomes. Since they are chromosomes from single pair but they are not same, that's why we say heterologous pair of chromosome. So in males, 22 pairs of homologous chromosomes plus 1 pair of heterologous chromosomes. I hope all the terminology till here is clear to you. Autosomes, allosomes, sex chromosomes, homologous chromosomes, non-homologous chromosomes and heterologous chromosomes, plus DNA, chromatin and chromatid. Clear? Now last thing that we will be talking about today is ploid. What do we mean by ploid? Ploid is one complete set of chromosomes. As in the beginning I told you, why we have in pairs, why we have chromosome in pairs? Because one pair comes from mother, one pair comes from father. That's why they are in pairs. So one complete set. Suppose if I talk about this is one pair, this is second pair of chromosome, and so on till 23rd pair, right? So this one pair, complete one set of chromosome that came from mother, is known as one ploid. This one set of chromosomes comes from mother, so it is called as one ploid. And this other set of chromosomes, comes from father. So this is known as another ploid, one ploid. So in humans, we have two ploids, one set of chromosome from mother, one set of chromosome from father. So man is diploid. Please mark my words. Man is a diploid animal. Why? Because we have two ploids. Ploid means one set of chromosomes. This one set, not in pairs, but single, one set of chromosomes, another set of chromosomes. One set from mother, one set from father. One ploid from mother, one ploid from father. So two ploids. So diploid animal. Right? Now let's come back to from where we started. All these terms are clear to you or not? Please check. I hope DNA is clear to you. Chromatin, chromatid, chromosome. And the point where these two chromatids join to form chromosome, this point is known as centromere. Right? Then sister chromatids, these two are known as sister chromatids. Autosomes, pair number 1 to 22. Allosomes or sex chromosome, pair number 23. Then homologous chromosomes, chromosomes from one pair of chromosome. Non-homologous chromosomes from different pairs. Heterologous, if there are X and Y in one pair. Ploid means one complete set of chromosomes. Diploid means two sets of chromosomes, right? So with this, we completed the basic terminology of chromosomes. Now, if you will see over here in the syllabus, these topics will be very easy for you to understand because numerical and structural aberrations, that means errors in the numbers of chromosomes. Suppose I told you there are 46 chromosomes. If we have 47 chromosomes, that means it is a numerical aberration, error in the numbers. If there is a structural aberration, that means there is a problem in the structure of chromosome. So I told you about the structure of chromosome. This is the structure. Suppose this part is missing, this particular part is missing in the chromosome. That means it is a problem in the structural part. The part got deleted. So structural aberration. Sex chromosomal aberrations means aberrations or errors only in the 23rd pair of chromosome, X and X or X and Y chromosome. Autosomal aberration means errors in the autosomes, pair number 1 to pair number 22 of chromosome. So down Patau and Edward, I told you, Edward means in the 18th number, error in the chromosome number 18, Patau means error in chromosome number 13 and down means error in chromosome number 21. As I told you, PED 13, 18 and 21. Triducat, there is an error in the 5th chromosome, short arm of the 5th chromosome that we will be explaining. We will be dealing with it in our next lecture. Genetic imprints is totally another topic that I will be taking a separate class for it, right? So please stay tuned. In the next lecture, I will be explaining you about the errors, about these syndromes, Down, Patau, Edward, how exactly things are taking place. I hope you liked the video. All the concepts are clear to you. In case of any problem, feel free to mention it in the comment section. I will definitely come back to you and solve your problem, right? So have a good day. Thank you. Please do not forget to like, share and subscribe the channel. Thank you.